Good morning, dear students. My name is Ferhan Mazher, and the subject we are studying today is Physics 5054 Cambridge O Levels. We are working on the chapter The Solar System, and in this video, we are going to talk about the planets which are orbiting around the Sun. So this is a detailed video on the planets and their different properties. For example, their mass, radius, density, surface gravity, orbital speed, their average distance from the sun, orbit time around the sun, surface temperature, density, diameter, mass, surface gravity, and the number of moons around them. So I have already discussed this table in detail in my previous video, but I will show you this and you can pause the video so you can read this table again. The planets, the facts and figures about the sun, earth, moon, and planets are listed in the table 6.1.1 and 6.1.2. Times are given in earth hours, days, or years. As well as being of general interest, this data indicates factors that affect conditions on the surface of the planets and some of the environmental problems that visit or attempted colonization would encounter. So on your screen, the two tables are showing up. One table 6.1.1 is the data for the sun, earth, and the moon. The second table is data for the planets. So you can pause the video and you can if you want to read this very important, very informative table, both of them, you can pause the video and you can take your time with these tables. Okay, it can be seen from the table 6.1.2 on the previous page that a planet's year, that is the orbit time around the sun, increases with the distance from the sun. The orbital speed, however, decreases with the distance. Neptune travels much more slowly than Mercury. Surface temperatures decreases markedly with distance from the sun, with one exception. Venus has a high surface temperature, that is 460 degrees centigrade, due to its dense atmosphere of carbon dioxide acting as a heat trap, that is the greenhouse effect. Its very slow spin time of 243 Earth days means that its day is longer than its year of 225 days. Mercury also, with the slow spin time, which is 58.5 days, has practically no atmosphere, and so while its noon temperature, is 350 degrees centigrade. At night, it falls to minus 170 degrees centigrade. Mars is the Earth's nearest neighbor. It is colder than the Earth. Temperatures on its equator are rarely greater than 0 degrees centigrade, even in summer. Its atmosphere is very thin and consists mostly of carbon dioxide with traces of water, vapor, and oxygen. Its axis is tilted at an angle of 24 degree, and so it has seasons, but these are longer than on Earth. There is no liquid water on the surface, but it has polar ice caps of water, ice, and solid carbon dioxide. In some parts, there are large extinct volcanoes and evidence such as gorges of torrential floods in the distant past. Figure 6.1.8, Mars is now a comparatively inactive planet, although high winds do blow at times, causing dust storms. So here is that figure which they were talking about, the surface of the Mars as seen by the Mars Global Surveyor, showing a vast canyon 6,000 kilometer long, and layered rocks indicate a geological active history. Jupiter is by far the largest planet in the solar system. It is a gaseous planet and is noted for its great red spot. Figure 6.1.9 which is a massive swirling storm that has been visible from Earth for over 200 years. And that is this. Jupiter's great red spot pictured by the Voyager 2 space probe. So they are talking about this. This is the great red spot on Jupiter. So Saturn has a spectacular rings made up of ice particles, figure 6.1.10, which are clearly visible through a telescope. Like Jupiter, it has an ever-changing, very turbulent atmosphere of hydrogen, helium, ammonia, and methane gas. So this is the Jupiter. Sorry, this is not Jupiter. This is Saturn. Sorry, I said Jupiter. Saturn's rings as seen by the Voyager in the probe 1. So let me reduce the size so you can see this diagram. This is the Saturn's rings as seen by the Voyager 1 probe. Uranus and Neptune are large, cold, and windy planets with small rocky cores surrounded by an icy mass of water, methane, and ammonia. They both have rings and many moons. Their atmospheres consist of methane as well as hydrogen and helium. The four outer gas giants are able to retain these lighter gases in their atmosphere. Unlike the Earth, because of the greater gravitational attraction, their masses exert. The dwarf planet Pluto is smaller than our moon and has an atmosphere of frozen methane and nitrogen. It has 5 moons, the largest of which is Charon, which are thought to have formed in a collision between two dwarf planets early in the life of the solar system. The reddish brown cap around the north pole of Charon was found to contain organic molecules, which together with water can form chemicals needed for the evolution of life. Unmanned space missions such as Voyager 1 and 2 obtained much information about the outer planets and their many moons on flybys. The Cassini spacecraft spent 13 years orbiting and collecting data on Saturn and its moons before plunging into its atmosphere in 2017. Much of the information we have on the dwarf planet Pluto and its moons was obtained from the New Horizon spacecraft flyby in 2015. It also collected data on Jupiter's atmosphere, ring system, and moons on its outward journey. Mars has been comprehensively mapped by the Global Surveyor satellite, while the robotic vehicle Spirit and Opportunity, which were landed on the planet and roved the surface for many years, obtained extensive data on Martian rocks. Currently, the Curiosity rover is making its way across the Martian landscape, sampling geological features. On 26 November 2018, the InSight spacecraft landed on Mars with a large package of scientific instruments. The seismometers have recorded many Mars quakes, providing information about the planet's interior. The rover Perseverance, which landed on Mars in February 2021, will search for signs of past microbial life. It carries the Mars helicopter Ingenuity, designed to test if powered flight is possible for future human exploration of the planet. Gravity and planetary motion. In topic 1.5, we saw that to keep a body moving in a circular path requires the centripetal force acting towards the center of the circle. In the case of the planets, dwarf planets, and asteroids orbiting the sun in near circular paths, it is the source of gravity between the sun and the object that provides the necessary centripetal force. More than 99% of the total mass of the solar system is concentrated in the sun itself. So it exerts a very high gravitational attraction. The strength of the sun's gravitational field decreases with distance. So the further a planet is away from the sun, the weaker the centripetal force. This results in a lower orbital speed and longer orbital periods. The moon is kept in a circular orbit around the earth by the force of gravity between it and the earth. So that's it for today, and I hope that this will help you. So my advice to you is always that please watch more and more videos on the solar system. And I am working on the solar system from two books. This book, this video right now, which you are watching, this book is from the IGCSE book, and I am also using another book. So watch my videos, also watch the videos from the YouTube on the solar system. That will open up your mind, your imagination, your concepts, and you will master this concept. Once we have completed these reading sessions of these two chapters from two different books, then we will start working on the exam questions on the solar system. And obviously, this topic is first time entered into the Physics 5054. So we will take the exam questions of the other papers, for example, IGCSE, for example, the Physics 9 to 1. And from their questions, we will practice these concepts. We will prepare you for the exam, upcoming exam. So thank you very much for watching this video. Please subscribe my channel. Also like this video, share the link of this video with your friends, family, junior students, senior students, with your teachers. That helps me promote my channel. Thank you very much. Have a good day, and God bless.